we've been able to factor all of our stuff so far. It hasn't been that big of a deal. When you think back to that first section we did in 5.2 with some of the factoring where you said no or not factorable, well, you could have factored it. You just didn't know how to yet. I know. Crazy.
That's not okay.
Okay. So what's happening here, guys, is what I wrote on the board here is kind of like your generic form of a quadratic equation. I'm sure you've all seen that before. Your quadratic equation always goes ax squared plus bx plus c equals 0. A, B, and C's are constants. There's a bunch of little rules here and there you don't really need to worry about at this point. And you guys, what we've done is we've taken the product of A and C to add to the sum of B and factor. Well, it doesn't always work that way. For example, what happens if you have x squared plus 10x minus 3 equals 0? And I want to factor that. I want to find the zeros. Well, as of right now, we'd ask ourselves, what times what's negative 3 to add together to get 10? Negative 5 times 2 is negative 3?
No.
See what I'm saying? It's what times what is negative 3 to add to the middle term. Can't do it, can you? You're not going to get integer values to make this clean. So this is where completing the square comes into play. Completing the square along with using the quadratic formula are two methods that will always, always, always work. One of the things you'll find out is that working with the quadratic formula, which we'll do, maybe we'll do a little bit tomorrow, I don't know, it depends on our time, is that can get time consuming because there's a lot of numbers going on and a lot more simplifying via the radical than you probably need to worry about. Whereas when you're working with completing the square, it's a very simplistic process to solve any quadratic, to get your 0. Any one of them, okay? You can use any quadratic to complete the square. Whether or not you can factor it or not, it still works. What's that? Oh, what did you say, Christian? Oh, never mind. So what we're going to do here is we're going to kind of build off of just these letters real quick. In order to complete the square, what you're trying to do is you're going to create a perfect square on one side of the equal sign. And how you do that is the following. And this works every single time. So let's continue. Let's work with this one. It's the same one I just had up there. The steps in which you follow for the completing the square, there's like 3 or 4 of them, and they're always the same. The first thing you always want to do is move your constant. Move the value of c. How do I move a negative 3? I add it. So I write it out as x squared plus 10x. I want to get you in the habit of doing this. Blank equals 3 blank. Why? I'll show you in a second. Yeah, there's a couple of things you guys have used this for. Okay. Now, the reason why I'm putting those blanks in there is because I'm going to create a new trinomial on the left. The trinomial on the left is going to be a perfect square trinomial. What's half of 10? Okay. Here's what you do. You take half of b. So half of 10 is how much? 5. Okay. Square it. So you're going to add 25 to both sides. Okay? Look what you just made on the left. What times what is 25 that you add together to get 10? 5. You created a perfect square on the left. What was your half of b value? 5. So that half of b goes here. Was it a positive 5 or a negative 5? That's why I wrote x plus 5, quantity squared, equals, well, what's 3 plus 25? There you go.
Wait, so you automatically bring down half of b?
Half of b always, always, always goes in the term in the parentheses. When you square it, is when you square that to both sides.
Is that also going to work when it's equal to 0?
What do you mean?
Like, no.
What's that? No. Nope. What I did here, guys, if you look at it, by taking half of b and squaring it, I'm adding 25 to both sides of the equation, therefore maintaining the balance of the equation, right? Nothing's been lopsided here. So everything's still all good to go. From there, I'm just starting to combine up. Yes, ma'am?
So what if
Did you get excuse me, then you just get a fraction. It works just the same. It works just the same. We'll something like that later, okay? Now, this looks like a problem you've done 2 days ago. What do you do first? Square root it. What happens when you take a square root over an equal sign? Plus or minus. What's the perfect score hiding within 28? 4, so it becomes?
2, 7.
Good, very good. So you get this can equal plus or minus 2 root 7. How do I move the 5? There's your two solutions. Those are your two zeros for a trinomial that you were not able to factor before because they didn't give you integer numbers for zeros. Yes, sir.
Factor anything.
Anything can get factored like this. It's a very easy process. Okay? It's very, very easy. We'll do some more, and I'll throw an odd one in there for you.
Oh
Waiting.
Sorry, still coming.
No, it's okay. It's all right.
So what are the 4 steps?
We're going to go through it, and I'll write them out. I just wanted to show you the flow first.
Wait, those weren't the 4 steps?
I didn't write down the specifics. I just did it. We good?
Wait, so there's only one solution?
Yeah.
No, there's 2. Negative 5 plus 2 root 7, negative 5 minus 2 root 7.
Oh, okay.
All right, here you go. X squared minus 16x plus 76. I guess for the lack of better ideas here, your first step, move C if needed. Sometimes it's already over there. So the first 3 steps are extremely straightforward. Move C, okay? How do I move a positive 76? Subtract it. So I have x squared minus 16x blank equals negative 76 blank. Okay? What's half of negative 16? Negative 8. That negative 8, like Christian was saying a little bit ago, it drops into the term. This value is always going to be whatever half of b is. It'll always be that. Because what's negative 8 squared?
64.
Half of b, square it, add it to both sides. Those are the first 3 things you do. I know a lot of you guys reached for the calculators right off the bat and divided negative 16 by 2 and then squared it. It probably said negative 64. Put parentheses around it or actually trust your brain. Okay? Now, from there, it's extremely straightforward. You solve it like you would 2 days ago. What's negative 76 and 64? Uh-oh.
We need an eye.
We need an eye. Why not? Remember I told you guys yesterday what happens when you have, when we start talking about all those I values? Your workload has doubled. The amount of problems have doubled now. You have positive and negative answers.
Yep.
Oh. Might as well start with it. So square root both sides.
Plus minus 2i.
Very good, very good. X minus 8 equals plus or minus 2i root 3. And then lastly, what do I do?
Add the 8.
Add the 8. Very good, very good.
I like this design. This is fun.
Good. It's not supposed to be scary. And like you guys were saying, it really is a very simplistic way to factor. Okay? It's a very, very simplistic way to do this. And it does work even if you have terms that you just didn't know how to factor.
Why do they say this for algebra?
It's in the Algebra 1 book.
No, I know, but we don't really focus on it.
Because in all honesty, you don't really
It's
see
not
it.
very hard.
No, you don't see it very often in the Algebra 1 stuff. You see it a lot more in Algebra 2 because eventually, I was talking about this with them with third hour. Eventually, we're going to get to something called a hyperbola. Hyperbola. And a hyperbola has an equation.
Learning this, you just
Write it down. Or we got the back of this. Okay.
A hyperbola has an equation that looks like that. Hold on. What I want you to see here is these are two perfect squares. Do you agree? When you get to something with a hyperbola, we're going to have it written out as 7 or 8 terms that you have to group to complete the square to set up to be able to graph something that's going to look like this.
Looks like 2 tongues.
What?
Look at section 10.6 in your book, and that's where this comes from.
That's this.
We're not there, but this skill of completing the square is a very common thing for conics. Conics are curves, hyperbolas, ellipses, parabolas, circles, all those things, and all of them can be written as perfect squares. We use this a lot in Algebra 2. That's all. All right? We're not there yet. We'll get to this. This is actually, believe it or not, this looks like it's god-awful. Relatively easy. Just a matter of pulling out a couple of coefficients and plotting some points. It is very, very easy to work with. So, let's do an odd one. We haven't done that yet. Let me get one of those.
Does it matter if it's odd or even?
No. Sometimes if they're an odd number, people start to freak out. So I try not to let you guys worry too much, but
Why do they freak out?
because they don't know how to work with fractions.
I thought we were talking about the round.
So let's work through a problem. Let's work through a problem that has an odd number with a b value. Ladies, enough with the phone. Okay, put your phone away. Put it here first. I'm done asking you about this, okay? In this case here, we're going to follow the exact same rules. First thing we're going to do is what? What's that? Math. Besides math, what is? Add the 1. X squared plus 3x blank equals 1. Okay? Now, half of b. Well, no fraction, no decimals. Half of b is 3 over 2. Do we agree? Okay. If I square that, 9 over 4. You're right, but think in terms of fractions. You square it, you add it to both sides, you get 9 over 4. Everybody agree with me on that? All right. Your term, well, half of b was just 3 over 2, correct? So it's x plus 3 over 2 quantity squared equals. Good. What I was going to suggest here at this point, when I add 1, to the 9/4, I'm going to add it as 4/4 to 9/4 to keep the common denominator. And like Christian said, it's 13/4. Okay? What?
How'd you get 9/4?
What's 3/2 squared? What's 3 squared?
I
Don't use decimals. What's 3 squared?
Not bad.
What's 2 squared?
4.
So what's 3/2 squared? There you go. Don't use your calculator.
What happens to the 9/4, like the C value on the left side? Like, how do you skip to x plus 3/2 squared?
Here?
Yeah, like how do you like get rid of the
Go from this?
Yeah.
Okay. What's happening here is what times what is 9/4, but you add together to get 3/2.
Oh,
1.5 times 1.5 is 9/4. 1.5 plus 1.5 is 3. That's what it is. Okay? Now at this point, what do? Square root it. So you square root it. Can I simplify either one of those square roots?
Yes.
Yes. What's the square root of 4? Oops. So I'm left with x is going to equal -3/2, because I just moved it over to the right, plus or minus root 13/2. The process doesn't change if it's a fraction. You just have to remember to square the top and the bottom. Okay? Sure, make you drop. It's just halves. Think about it. If we're dealing with taking half of an odd number, your denominator is always going to be 2. 2 squared is always going to be, the square root of 4 is always going to be, yes, sir.
Step 4 is just solve, right?
Yeah. That's just kind of the generic. All right. It's hopefully not so scary, right? Let's do. I think this is a 0. Solve it, please. Solve it. Don't get angry at math. Math didn't do anything to you. Math didn't Jeez Louise.
Something really great.
Don't worry. They're always class days and all, right? What was your first thing you did? Subtract 17, so you got x squared plus 10x. Blank equals -17. Now what?
Then you have to do 10 divided by 2 squared.
All right, 10 divided by 2 is? 5 squared is? Add that to both sides.
8 on 2.
So x plus 5 quantity squared equals? Oh, this one's easy. What's the square root of 8? Very good. So you get x equals -5 plus or minus 2√2. Completing the square is nice, isn't it? All right. Tomorrow we will do this with the leading term coefficient not equal to 1. We'll do stuff like this. Now, yeah, there's a little bit of a. I need to remember that when we do this with the leading term coefficient not equal to 1, you're basically doing GCF stuff. But there's a reason why we don't do a few things, and I'll explain that tomorrow, and it kind of goes back to working with that hyperbola stuff. Not going to get to this today. I didn't get to it in the other class. I'm not going to bother pushing with you guys now. What we'll do tomorrow is we'll kind of blend this stuff together with the other things we've worked on. Maybe, I don't know if we might just jump into the quadratic formula stuff tomorrow, because that's relatively easy, especially for a Friday. And then just kind of let you guys do a combination of everything. No, it's not. It's short scheduled by about a minute. Because all they do is give it a flex, and there's 30 minutes right there. So, yeah, the class, your first hour is longer by a minute, so they do the announcements, and then everything else might be a minute shorter. So, don't think you're getting less class time tomorrow. It's not that big of a deal. Yeah, tomorrow there's no flex, so there's an assembly. Let's see, this is on page 287. I want you to do those, please.
Is that all?
Yep.
And there's just some stuff we're doing.
Stuff we're doing right now. That's it.
You know, that's what
The problems do take a little.
I can give you more if you want. Makes two of us.
I actually like.
I knew we agreed on something.
No, it's all good. I just don't like algebra.
All right. Go ahead and start this up here. If you don't have your book, I'll pull it up on the board so you can get a couple.